Now, scientists are hailing a major discovery, a new planet, which they've called Proxima B. At just 4 light-years away, it's relatively close to us. It's roughly the same size as Earth, and because it's just the right distance away from its probe, I'll see it so light lines at lace. Look at this, and we all know I've been exploring, that path, which they've called Proxima, be it just for light. Where are we sees with coarse cases? At core it's relies. As we are seizing with, we see if we see sees gway for like to see where I cad with see with ATH chef at K Koi when I see with core to kaki with commute be kai to see to like to see with youth so I you to sue so I can like I fit you to die can we the kai I ka kak you to go with the did I ka fake have you cutie that cat would have that go with grow with the acuity which keep we can coming like I've wait I the guy that's star, it could be the right temperature at which water can flow and perhaps life can exist. But look beyond our solar system to the next nearest star, Proxima Centauri, 24 trillion miles away, which seems like a lot but is in space, our neighbor. It is slightly larger than Proxima B, about 50% bigger than Earth. Although its star is much cooler than our sun, the planet is in just the right zone for liquid water to exist on its surface, which indicates that, in theory, it could support life. NASA has discovered a super-Earth that could have conditions to sustain life. The new exoplanet is 137 light-years away, or roughly 800 trillion miles. Astronomers say the planet is about 1.5 times the size of Earth and revolves around a tiny reddish star that is cooler than our sun. Quite exciting. I mean, we haven't found an exact twin for Earth. This isn't an exact replica, but out of this latest haul of 500 new possible planets, this one stands out. NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is already more mysterious, more beautiful than humanity's dreams. This is a huge discovery. We believe that the most exciting part is the discovery of this remarkable instrument we've put in space. It's finding things that we didn't expect, that we can't explain. Because that means our understanding of the universe must be revised. It is phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful. The James Webb Space Telescope has captured something truly astonishing, lights that resemble those from a city shining from a distant 0.7 trillion miles away. This discovery has sparked curiosity about the possibility of life on other planets. The telescope zoomed in on Proxima Centauri B, the closest exoplanet to our solar system, and found strange, bright lights. Could these lights be signs of another civilization? Let us explore how the James Webb Telescope uncovered these phenomena that will alter our perception of the universe. Glimpses of alien life from a distance have excited long-term researchers and everyday people alike. Any small bit of evidence that hints at the possibility that there is something out there is eagerly received. Then came a revolutionary moment when the James Webb Space Telescope provided clear signs of life somewhere in space, as this powerful telescope explored the vastness of space. It spotted something intriguing regarding Proxima B, an exoplanet far away. It noticed lights that looked similar to the lights you observe in Earth cities, suggesting the possible existence of an alien city. This concept of a faraway planet sparked a lot of excitement and curiosity among scientists. They are enthralled because this may be the kind of discovery they've been hoping for. It suggests that there could be intelligent individuals organizing their societies in ways we can't yet fully comprehend. And we are just now beginning to see evidence of it. Looking at these distant city-like lights, which are an incredible 7 trillion miles away, engineers are amazed and wonder how long these lights have been visible in space, just awaiting our acquisition of the technology to see them. David Kipping, an astronomer at Columbia University, outlined a planet on which these lights were found is quite complex. This is because, unlike most rocky planets that absorb and release infrared light, this exoplanet's energy behaves differently due to its relationship with Proxima Centauri, its host star. This finding by the James Webb Space Telescope highlights its importance. The telescope's ability to pick up infrared wavelengths was key in detecting the unusual thermal signature of Proxima B, essential for comprehending the planet's atmospheric conditions. Researchers plan to continue making use of this telescope to delve deeper into the atmosphere of this planet and even explore whether it might be habitable. The James Webb Telescope is particularly sensitive to infrared light, which allows it to observe what happens on Proxima Centauri B during the night. For numerous space telescopes, it is challenging to detect faint lights in the vast darkness of space. But the James Webb Telescope can detect even the tiniest flashes of light. This makes it an ideal tool to confirm whether the so-called city lights on the dark side of Proxima B are real. The telescope is able to detect any artificial light in space if it falls within a very narrow frequency band, much narrower than regular starlight. Proxima B has a dynamic relationship with its star. On the planet's daytime side, numerous potent energy sources are captured by the star's spectral edge and reflect light as the planet orbits around Proxima Centauri. It experiences cycles of day and night similar to Earth, with daytime high temperatures and cooler temperatures at night. The planet experiences significant temperature differences, which are largely determined by the composition of its atmosphere. If Proxima B lacks an atmosphere, the temperature difference between day and night would be extreme, without the moderating effects of atmospheric gases or oceans. The day side would get very hot, while the night would fall into freezing temperatures. This dramatic temperature variation is a key area of interest for astronomers, as it offers insight into the atmospheric composition of Proxima B. The James Webb Space Telescope's unparalleled infrared imaging capabilities can effectively examine the planet's temperature emissions, providing valuable data on its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around Earth has the same orbital period as Proxima B, approximately every 11.2 Earth days. If the planet indeed has an atmosphere, the next step will be to examine its atmospheric chemistry to determine if it can support life. Signs such as the presence of water, vapor, oxygen, and methane would indicate habitable conditions. If these elements are present on the planet, it would confirm its potential to support life. This necessitates accurate capture and analysis of light passing through the planet's atmosphere. A challenging task, although the James Webb Telescope has excellent capabilities for characterizing planetary atmospheres. It is primarily designed for other tasks, specializes in analyzing variations in the concentrations of water vapor, carbon dioxide, and methane. While it has some limitations in detecting bonded oxygen, a crucial indicator of life, the telescope is also equipped to search for other essential components, like ozone, which is a good indicator of a healthy atmosphere. As scientists consider the search results from the James Webb Space Telescope to explore faraway worlds, it brings us closer to knowing if we're alone, exploring new worlds. It's important to remember that the James Webb Space Telescope can only observe a limited number of the closest habitable worlds to Earth. For more detailed atmospheric studies, astronomers are turning to ground-based observatories, like the Extremely Large Telescope (ELT), which is set to begin operations in 2028. The ELT is designed to provide deeper insights into the atmospheric structures of distant exoplanets, offering detailed and clear data on their potential to support life. Scientists are eagerly awaiting the operation of future space telescopes like the ELT. In the meantime, however, the James Webb Space Telescope is still an important tool in our quest to explore distant exoplanets. Despite its limitations, the Webb Telescope continues to offer profound insights that could revolutionize our understanding of what lies beyond our solar system. Both now and in the future, Space exploration is a priority for researchers. Telescopes of tomorrow aim to tone down the stars' bright glare so we can learn more about the planets orbiting them. Think of it like using your hand to shield the sun's brightness so you can see better. By reducing the brightness, these upcoming telescopes will have a better idea of how to study the faint light bouncing off distant planets. This will help them analyze the planet's atmosphere and check if it could support life. But this task isn't straightforward. Scientists will need to distinguish between gases produced by living things and those from natural activities on the planet, like volcanoes. They are genuinely interested in getting to know these faraway planets better, so they can detect actual evidence of life without being fooled by natural processes that look similar. From the Webb Telescope, we get a glimpse of what these upcoming studies could reveal as we keep pushing the boundaries of our knowledge and getting closer to understanding the complex universe and our place in it. Since the beginning, humans have wondered if we're alone in the universe. This question still drives numerous research studies currently underway. The James Webb Telescope is out there in space, checking out different planets and moons to see if any might be home to alien life. A lot of people now think that aliens might actually exist somewhere in the cosmos, just waiting for us to discover them. To try to answer this age-old question, two American astronomers, Thomas Pearson and Jill Tartor, founded a project in 1984 known as the Search for Extraterrestrial Intelligence SETI. They set up a nonprofit to listen for radio waves from outer space because radio waves can travel really far without being absorbed or lost. They use the Allen Telescope Array in the mountains of California, which has 42 radio telescopes designed solely for this purpose. Despite looking for over 30 years, SET hasn't found any radio signals that can be said to originate from aliens. However, Jill Tartar retains hope and believes that with today's technology, they might finally find something. She's even stated that she wishes all people on Earth would join in this exciting search for company in the cosmos. Recently, there's been some buzz as a result of NASA's report that the James Webb Space Telescope might have seen lights from a city on a planet not too far from Earth. The JWST is really the best tool we have for exploring space right now. It's hanging out 1 million miles away from Earth, sending back detailed info about the oldest parts of the universe. It's specially designed to pick up details that we've missed before, helping us understand how galaxies, stars, and planets form. Astronomers are making the most of the JWST's advanced technology, like its super sharp camera and special filters to look at and understand the subtle colors around planets and stars. They rely on this telescope to learn about the physical and chemical makeup of locations that are light years away by picking out certain wavelengths of light. The Webb telescope isn't just observing. It's actively searching the atmospheres of other planets for the tiniest hints of life. Using its unmatched ability to sift through time and space, it has already made astonishing discoveries, such as finding way more mass in the universe than we thought, hidden in big galaxies. This has made scientists rethink some of their ideas about how the universe started and grew. With each new discovery from the Webb telescope, our drive to comprehend distant planets deepens, expanding what we know about life beyond Earth. New information and the quest for aliens continues to fuel humanity's curiosity as we use advanced technology to explore the cosmos. The JWST is set to go deeper into space than we've ever gone before. It's helping us gather information on remote worlds, providing new insights that could solve some big questions about these distant planets that we barely knew anything about 20 years ago. Planets outside our solar system, known as exoplanets, have since been discovered in abundance. Astronomers have found over 4,000 exoplanets orbiting distant stars, showing just how far we can test our curiosity and technological abilities. However, NASA believes that these discoveries are just the beginning. They believe there are actually trillions of exoplanets out there waiting to be found. Scientists haven't stopped their space explorations, wishing to locate locations where aliens might live. Every so often, they get a hint that they might be on the right track. For instance, when the Galileo spacecraft went to Jupiter, it accidentally found a sign that may indicate plant life out there. This was a huge deal because it was the first time we found what's called a biosignature, which in this case was a vegetation red edge VRE. The VRE looks for life in a unique way by checking how light bounces off it. With the assistance of VRE, the James Webb Space Telescope is all set to uncover more about life in space, mapping out the orbits of planets that could be cozy enough for life tucked away in the right zones around their stars. When these indicators pop up, the virtual real-world engine VRE could shake things up by pointing us toward intelligent life somewhere beyond Earth. This could kickstart an exciting phase of space exploration that digs into the dimensions of the cosmos that are unknown. This light shines through a variety of atmospheric layers, breaking into rays of different wavelengths, which atoms and molecules in those layers snatch up. As this process keeps going, it creates a unique spectral signature. Consider it to be a special kind of fingerprint that we can read using a method called spectroscopy. There is a firm conviction among scientists that when a planet gets bathed in starlight, the Webb telescope will catch that light as it sneaks into the planet's atmosphere. This bit of insight hints that the James Webb Space Telescope may be the most important component. We have been unable to determine what the atmospheres on these distant planets are actually made of. Planets about the size of ours usually have a mix of carbon dioxide, nitrogen, and oxygen in their atmospheres, making these planets possible life support systems. But the absence of stranger, rarer compounds might hint at different kinds of life forms and even advanced civilizations out there. For example, chlorofluorocarbons CFCs, chemicals produced by humans used mainly for cooling in fridges and in various industries, could be a clue. If the JWST spots these synthetic chemicals in a distant planet's atmosphere, it would be solid proof that intelligent life exists beyond our solar system. Such a discovery would significantly broaden the scope for astronomers, giving them a whole new playground to investigate the atmospheric makeup of other planets, and even the slim chance of civilizations far beyond the Milky Way. Thinking about life beyond Earth opens up numerous possibilities that go way beyond what we see and experience in terms of biology right here at home. Often we imagine life requiring a pleasant, mild climate to thrive, but the reality could be far more varied. Likewise, extremophiles, for instance, the majority of which are bacteria, toss our usual ideas of what makes a place livable right out the window. These tough critters manage to survive and even thrive in conditions that would seem downright apocalyptic to other organisms. They can withstand boiling hot temperatures of up to 250 degrees Fahrenheit. And can even thrive in superacidic conditions where the pH dips below 3. Their very existence is a powerful reminder of how resilient life can be, even under the most intense and unforgiving conditions. As the search for life-supporting worlds takes new turns, the chance of discovering life in unexpected settings challenges what we know about the universe, the search for life in unusual places. Given the vastness and diversity of space, really suggests that our search for life out there has to be broad and comprehensive. Planets that look a lot like Earth in orbit, stars similar to our Sun, are an excellent place to begin this kind of research. But it's also really important to keep an open mind and consider less typical scenarios, like exploring exoplanets that circle around red dwarf stars, which are pretty common. In spite of the fact that these stars are dimmer and less welcoming than our Sun, they offer unique settings to check out life's potential in varied environments. The longer lifespan of red dwarf stars also gives plenty of time for the lengthy and complex procedures involved in life's evolution to take place. The TRAPPIST-1 system, for example, features a dim red dwarf star and 7 rocky planets, much like Earth, orbiting around it. Out of these, 3 are thought to be in the habitable zone, which suggests that they may contain liquid water on their surfaces, despite being smaller and less warm than the Sun, which keeps us on Earth. The TRAPPIST-1 star sends out a gentle illumination that could help life. By studying the light emitted by the star, scientists hope to discover information about the conditions of living that might exist within the TRAPPIST-1 planetary system. After conducting extensive research, discovered this particular star, 41 light-years away from us. Located in the constellation of Leo, promising spot. For further investigation, Ward Howard, a NASA Sagan Fellow and the leading researcher on this study from the University of Colorado Boulder, couldn't conceal his enthusiasm for these discoveries. He mentioned that, thanks to the JWST, this is the first time we've had the ability to look for planets around other stars that have secondary atmospheres similar to what we have around Earth. He stressed how crucial it is to comprehend these stars in order to truly get what's going on with their planets. Among all the stars scattered across the cosmos, Proxima Centauri really stands out due to its proximity. It's only about 4.25 light-years from the Sun, making it the closest star to Earth. This star emits only a faint glow, which is tough to spot in the dark night sky from our planet. Its dimness means any planets that could possibly support life would need to orbit much closer than Earth does to the Sun to maintain favorable conditions for life. Back on August 24, 2016, astronomers discovered something really cool. A planet with 1.3 times the mass of Earth, perfectly positioned within the habitable zone of Proxima Centauri. This zone strikes just the right balance of lightness sufficient to melt ice, and Proxima B might give life a foothold. A fascinating planet that orbits the small red star known as Proxima Centauri is located 4.6 million miles away from its star. This close proximity to it is subjected to a wide range of dangers that could make it hard for life to thrive there. One major obstacle is the intense solar winds from Proxima Centauri, which are powerful enough to potentially strip the planet of its atmosphere. Despite these harsh conditions, Proxima B receives sufficient rays from its star to remain warm, enough to maintain liquid water, a crucial ingredient for life as we know it. The close orbit of Proxima B around its star also results in a phenomenon called tidal locking. This means that one side of the planet always faces the star, receiving continuous sunlight, while the other side remains in constant darkness. This unique situation creates a stark contrast between the two hemispheres. One could be basking in perpetual daylight, while the other could be frozen in an interminable night. Somewhat akin to the relationship between the Moon and Earth, where Earth always lies on the same side of the Moon. Despite its relatively modest size, Proxima Centauri is still capable of emitting enough light and heat to potentially support an environment that could host life, not unlike conditions that exist on Earth. Could these strange cycles on Proxima Centauri be a sign of alien life, or could there be another explanation we haven't considered? What do you believe is the truth behind this discovery? Share your thoughts in the comments, and don't forget to like and subscribe for more.